Welcome, Aggie.
Hello. Okay, we ready to start?
We are fantastic.
Okay, everyone. Welcome to Honey, I Shrunk the Disks, a beginner's guide to data recovery. A little bit about me before we start. I'm from South Wales. I'm a security engineer. I run a free data recovery service for the local community around South Wales. And I also happen to be 3 red pandas in a trench coat on Twitter. So this is going to be broken down into 2 parts. Part 1 is your basic theory. So we're going to cover disks, partitions, how they all work. Then we're going to do file tables, what that means for us in the data recovery process, and then file carving. So how to extract files when we otherwise wouldn't know where they are or how to get them. Then we have part 2, which is going over the equipment that you need for a lab and the tools you need and how to use them. So to start with, we're going to have a primer on data storage. So your disk is organized into partitions. So your hard drive will have like C on Windows and any other stuff. So if you had like 2 partitions, you would have your C drive and your D drive. Those partitions are a range of blocks on your hard drive, which technically point to sectors, but we're going to skip sectors. And it defines a range of bytes that we can read or write to, so we can access binary directly. So this is an abstract representation kind of a hard disk. There is a little block up in the top that's blue. That's our MFT, our master file table. And that tells a computer where 2 other files in this case are. We've got Panda and Panda in Snow. And you see the MP4 is a little bit bigger, so it takes up a couple blocks. Without anything to tell us where the file is, we'd have to scan the entire disk every time we wanted to access it. That'd be very slow. So when we format a partition, it gets these file tables in Windows or on NTFS. It's called the master file table. Different partitions will have different things like inodes in Linux that help us easily access things on the disk. This will arrange, all the data that you've got into files and folders that your computer can then see and work with like normal. So MFT will define how big your file is, where it is, and that kind of thing. Now, if you put something in the recycle bin, or you just hit normal delete on your keyboard, it'll go into Windows recycle bin or Linux trash. At this stage, the image is still there. Obviously, you can click into your recycle bin and bring it back quite easily. It's because there is a record of it still in MFT. So we don't need any tools to recover that. We're not particularly concerned. But if you were to, say, hit Shift Delete, that removes it completely. So the MFT doesn't have a way of telling you where that file is now. It's unallocated space. That means that whenever a new file comes along and it's like, where can I be put on the disk? Then it'll just go right on top of where we've deleted the file, or there's a chance of doing that. So unallocated space is just free space on a disk. But in this case, there's a little hidden Panda there that could get overwritten, and we don't want that to happen. So we're going to do some data recovery. If things get really bad, your whole MFT could be corrupted. Maybe your hard drive took a really bad knock, or you tried to format your disk in a really weird way and everything's just gone wrong. So you don't have anything to tell you where any of your files are. This is pretty rare to have something like this happen, because MFT will have little mirrors, so copies of itself throughout the disk to kind of fall back on in an emergency. But this is a nice hypothetical for the situation we're about to go into, where we don't know where anything is. So we're dealing with a complete unknown and we want to find all of the pandas. So our MFT doesn't tell us where anything is. There could be more than just 2 pandas here. There could be all of these just hidden on your disk. So there are tools to repair the MFT. We're going to ignore those for today, and we're going to go straight onto a process called file carving, which is where you go block by block on the disk and you try and find something called a file signature. These file signatures are little strings on a disk or little bits of data that tell us what a file is. Each file type has a unique signature. It's usually defined by a standard. So PNGs have the same first 8 bytes to them, and then they have an end of file. So what a carver will do, if it has the definitions, it knows what to look for at the start and the end. It'll go block by block until it finds the start of the file, and it'll keep going till it hits the end, and it'll go, this is a file, and alert you to do what you want with it. It takes a long time to do file carves, even on small disks. When I was testing this, I had a 250 gigabyte hard drive, and it took, I think it was 2 hours to complete the entire carve. So this isn't something that you want to do if you've got, say, a 2 terabyte drive, or if you do, and you're really desperate for those files, you might want to leave it running over the weekend or overnight. File carvers will need somewhere to store their information because they don't just throw it back into the file table on the disk that they found it. If they did that, you'd be writing to the disk you were trying to save files from, and you might do something dodgy to your own data. So you might accidentally lose a panda or any file that you need. So we need a lab to work on this, or a separate disk to put all the data. So carvers will work in one of 2 ways usually. Either they'll dump all the images that they find or all the files that they find straight onto a place that you've told it to. That's quite heavy on data. You would need a lot of space, and then you need to sift through to find the few images that you really wanted to get. Or we can use Autopsy, which has a module called Photorec. And what it does is it'll tell you where these files are, and it'll give you information about them so you can decide what to do with them. So if you had 1 million images and you only wanted 20 of them, you can use a very small disk to recover those 20 images. You don't have to get the 1,000 and then, or the million, and then sort through to find what you want. So that's a quick primer on the theory. We have a 5-second snack break to process everything before we move on to the practical side of things. So you know how disks work now on a basic level, just enough to understand the file carving process. In terms of equipment that we need, we're going to need some kind of storage drive. So it works on basically anything that you need it for. Any data storage device will work as long as you have the adapter to plug it in to your machine, whatever you're doing your data recovery on. So if you have a USB to SD card adapter, you can run micro SD. If you have SD card adapters or SATA cables, you can use anything you want because it doesn't matter what the physical form of the disk is. As long as it is readable, we can work with it. So I pulled the hard disk from one of my servers, and this is formatted in NTFS. It has a little extra reserved space on it, so it might show up as 1 partition or 2 or 3, depending on how we look at it in Autopsy. It's a quick review of how my lab is set up in theory. So to recover our pandas from our hard drive, we're going to need our hard drive that I pulled out of the server. and then you're going to need a SATA to USB connector, just so it can pull the data, and then a recovery lab, which you can just put an operating system onto a laptop with Autopsy. I'm using an OS called Kane. It's based off of Ubuntu, and it contains Autopsy as well as a bunch of other forensic investigation tools, which helps us not cause any damage to the disks that we're working on. If you don't want to sacrifice a whole PC to your data recovery, you can just put it on a USB and do a thing called live booting, which is where kind of your USB will act as the hard drive that your machine boots off of. And you can just use that instead. It's a little bit slower, but it works just as well if you have a few images you want to get off of a USB disk or another hard drive. So this is what Kane looks like. I've arranged things so they look a little bit neater. There are a couple extra tools that I've disappeared to get rid of the clutter. We're going to be working with Autopsy, and we're going to be working with Unblock. Unblock is our write blocker, which we're going to check in with first. So Unblock allows you to basically choose whether or not your disk is read-only. So you see we've got a 40 gigabyte disk, which is our lab, and a 250 or 232.9 gigabyte disk, which is going to be all of our missing data. To change whether or not these are readable and writable, get a little tick box on the left, and you can just hit the OK button once it's ticked. It'll switch it round and bring the screen up again to tell you its status. We've been given the device names SDA and SDB. This is standard Linux naming convention for disks. It'll be SD and then ABC in order of how the disks are connected. We know that we plugged in a 250 gigabyte disk, so the 232 is almost definitely our missing data, and that's how we can tell. There are other ways of looking it up, but we're not going to use command line today because this is for absolute beginners with no prior history of using anything. Now SDB is read-only in the status field. We know we're not going to overwrite anything, so we can't cause problems even if we tried. That data is safe. Now, before you go into Autopsy, you can actually just look at the disk for things that are in the recycle bin. Like we said earlier, it's really easy to just go into the recycle bin and then find all your files. Sometimes you want to do this just before the investigation to get an easy win in. If you're looking for files and you just want a quick 5-second thing while the disk's spinning up and while the investigation is going on in the background, you can hop in and you can read all of this. And you'll see there's recycle bin in there, which may be called Trash 1000 if you're using Ubuntu. But recycle bin and trash are the two places where you can look on a disk without any other software to find your files. If it's been properly deleted, you won't find them. But in this case, we have found a couple things hidden away in our folder. So when you get into recycle bin, you'll see that there's a big string of text kind of just under icon view in the top right. Recycle bin will have like an ID, which you need to go in, just an extra subfolder to work with. And then you get all of these files. We've recovered me talking about pandas to the Digital Overdose stuff. There's plenty of other files there we can look at, but that's not everything that is missing on that disk. We've done 2 examples here. I've deleted some and I've shift deleted some. So let's go find all the rest. We're going to use Autopsy. It does a little bit more than just opening a disk and looking at hidden folders. We can use Photorec to carve for files. And there are a lot of other modules that we can use. We're going to start with Photorec and just work with that on its own for now. So what Photorec will do for us is it'll read the disk for orphaned or deleted files. Any other data that hasn't been overwritten will be looked over for whether or not it matches the file types we want. Autopsy's free, it's open source, and it runs on Linux, Mac, Windows. It's designed to work on Windows. That's where most of the testing happens, but it works pretty flawlessly with Kane. So we're going to speed run the setup here. You can add in optional information if you want, but we're not too concerned with that. We just want to get our files. So we're going to open a new case. We're going to give it a case name. I'm just giving it test data today. At the base directory, you don't need to change. That's just where your project folder will be. So that's the path you're going to need to type out later when we get all our files and see where they've been extracted to. And then we can jump down, press next, hit finish, and it'll bring you to data sources. We want to add a local disk because we physically plugged it in. So SDB is a physical or a local disk here because it's not a logical file. It's not an image file or any digital stuff. Once you selected your data source, it'll ask you to pick your disk. So we know it's SDB, so you can choose SDB, or you can choose SDB1, which is the specific partition on that disk that we're dealing with. I'm going to choose SDB in this case because I want everything, even the unallocated space at the end of the disk and the extra little chunk at the beginning, which is where you're going to find stuff like a bootloader, just in case there's anything in there. We're going to be thorough. Once you've done that, you've got your ingest modules. This is where you pick all of the fancy tools that Autopsy has available to it. We don't need anything particularly fancy here. We don't need to look for encryption. We don't need to look for virtual machines. So we're just going to deselect all. And to make this all go quicker, we're only going to select Photorec Carver. That's going to be our file carver. It'll get the images that we're looking for. Now, you can see at the bottom, it's analyzing the disk. It's taking a long time to work, but while it's doing that, we can actually expand this directory tree and we can see what it's doing in real time. So as it finds a file, it'll throw it in to the data source and we can work with it straight away. So we're going to expand all those options, see what's available. And on the side there, this is what it looks like when it's fully expanded. So you'll see that there are a couple folders with a V. Those are special folders that are virtual. They don't actually exist on the disk, but they help us identify things. So that's where our carved files are going to appear in carved files. If you had any orphan files, they would appear there as well. And then there's all of the unallocated blocks. Unallocated blocks won't have anything particularly useful for us. It's just a way of, if you need to manually access data that you think is there but hasn't been found by your tools. Other folders are all indexed on the disk. So you'll see $extend, $recycle bin. Those exist. We can still access them, treat it like a normal file system as if it's been mounted and accessed by just a normal computer. So you can still go through the file system like that if you want to. We have other things we can do like showing results by file types. So if you wanted to filter down and you only wanted to see the videos, you can click that and it'll show all the videos that it's found and indexed from everywhere. So carved files in the recycle bin, if it's in both of those will both appear in images and videos. Then we have deleted files. Deleted files at the bottom is a special category that Autopsy has for defining anything that's in the recycle bin, anything that's in trash, and carved files. It's like an aggregate of everything that it classifies as things you shouldn't have been able to see. things you traditionally would have tried to get rid of, which is useful if someone has deleted your Panda collection and you wanted to go find it. If you head into deleted files, you'll see we've actually got all of the names of the things that have been deleted with their extensions, how big they are, and where they were before they got deleted. So in location, all of these images were put on the root of our partition. I just threw them straight on the disk and then they were deleted. You can right click these and you can hit extract file. That'll send it to a project export folder. We'll visit the export folder in a little bit, but we're going to look at some other places where we can grab those files and what they look like. These ones with the little X and the page, those are ones that have been recovered either from the MFT or in our recycle bin. And we have carved files. These have a slightly different icon to them, as you can see. And they also have a naming convention. So you can right click and extract these exactly the same as a deleted file. But one thing you have to bear in mind is that this method of carving files in Autopsy, it doesn't seem to retain the name. So while most of the other data is intact, the actual image itself, perfectly fine. You'll notice that you're missing image names. So all we have to do after we've exported all of our images is head over to, in this case, our root directory for our investigation, home, Kane, test data, which is what we called our project. And the export folder has all of the images that we've recovered. So we can determine the end result of our investigation, which is a lot of pandas. We found all the missing pandas. We did a mixture of file carving and looking through for deleted files using Autopsy. Now, most of the pandas today have come from zoos all around the world and organizations that help protect the red panda population worldwide. I'll show you in the Q&A in a minute, but you can give those organizations a little bit of love if you want to give them a little money or just a quick shout out with some links in the Q&A page. So, tools we've used today, we've used Kane as our operating system. We've used Autopsy to do all our file recovery tasks. If you have Kane, you don't need Autopsy, it's built in. And my Twitter link is just down there, and some accounts where you can appreciate red pandas, all on the right. I think that is just about time. So I think we can start a Q&A now and see what everyone thinks.
Yes. All the pandas.
That was so fantastic. I loved all the pandas. They were so cute. My little heart is so happy right now.
I have a small competition running on my Twitter page. If everyone wants to get the first answer for how many pandas there are and how many unique pandas showed up in the entire presentation, I might be handing out a little prize.
Ooh, okay. Alrighty, so should I get the first question asked?
Yes.
All right, so do you think Autopsy is user-friendly? Will beginners using Autopsy have any issues using it, or do you think Autopsy is pretty self-explanatory / well-documented?
I think Autopsy is very well documented, at the very least by the community. If you ever have a problem with how to run a basic autopsy investigation, there are a lot of videos and documents that are out there. They'll show you everything that you need to know, but it should be fairly self-explanatory. Going through the process, it's like a lot of click next. And if you see anything optional, you can safely ignore it and it won't affect you in any way.
Alrighty, good to know. And then another from Karam4567. Hypothetically, if Autopsy does not work, are there any other programs that are just as good?
Autopsy should work in theory. If Autopsy doesn't, then I'm not sure you're going to have much luck using other programs. I think there's something called Foremost, which is a command line tool which lets you scrape files for anything inside them, or allows you to scrape, say, sections of the disk and see if there are any files in there. But outside of that, I don't think there's many other tools that do the same kind of functionality or better.
Alrighty, awesome.
Awesome.
Thank you so much.
Well, thank you.